All right, so in this video, let's look at how to draw a control chart. That's basically what we're going to look at, is drawing the control chart. I'll go over real quick and show you real quick examples of the out of control signals. But let's go ahead and get started. So how do we make a control chart? So we want to find the mean and standard deviation, okay, for the X distribution, using past data from a period during which the process was in control, or using specified target values for mu and sigma. Create a graph in which the vertical axis represents X values and the horizontal axis represents time. Yeah, I see I misspelled represents. Draw a horizontal line at height mu and horizontal dashed control lines at mu plus or minus 2 sigma and mu plus or minus 3 sigma. Plot the variable X on the graph in the time sequence order. Use line segments to connect the points in time sequence order. Okay, so before we get to drawing the control chart, let's just go over the out of control signals where we might give us a false alarm, the data that we have. So this is basically what it'll look like, just a rough little sketch. Now here this is your solid line mu, and these are your dashed lines here at mu plus or minus 2 sigma and plus or minus 3 sigma. All right, so if we have an out of control signal 1, okay, that means we have a point above the mu plus 3 sigma, or we have a point below mu minus 3 sigma. Now you don't have to have both of these, just one or the other, or you could have both, okay? The next one, an out of control signal 2, you have a run of 9 consecutive points on one side of the center line where mu is. So if I have, say, 1, 2, 3, 4, 5, 6, let's see, 6, 7, 8, 9. So here's where I would have a run of 9 points on one side of the center line. That's what that would look like. It could be up here, or you could have it down here. Okay, so you could have your run of points above or below. You don't have to have both, one or the other, or you could have both. But that's what they're talking about there. And then if we have an out of control signal 3, that says at least 2 of 3 consecutive points lie beyond the 2 sigma level on the same side of the center line. All right, so what that means is we look at 3 consecutive points. Whoop. All right, sorry about that. I have no idea what happened. Crashed, PowerPoint did. All right, so the out of control signal 3, at least 2 of 3 consecutive points lie beyond the 2 sigma level on the same side of the center line. All right, so what we do is we look at 3 consecutive points. And if you have something like this, all right, so if we have something like this, well, let me say something like this, okay? There's 3 consecutive points. Well, you see how 2 of those lie beyond the 2 sigma line? That would be an out of control signal 3. Or you could have something like this. All 3 of them are above the line. Or you could, it could be something like this. Okay? And it doesn't necessarily have to be up here. It can also be down here if you have 3 consecutive points like this. Okay? So that's out of control signal 3. All right. So now let's get to drawing the chart, the control chart. All right, so what we want to do here is, remember what it said. It said draw the solid center line. So that is going to look something like this. Okay, that's the horizontal axis. That's our x-axis, and then we'll have our vertical axis. That's like the y-axis. Now remember, the middle line here, that is mu. This is mu. Okay. Now, what is mu? Okay. Well, let's look. The average number of visitors medically treated each day is 21.7. So there's mu. So this is 21.7. All right. The estimated standard deviation is 4.2. For a 10-day period, the following data show the number of visitors treated each day. Make a control chart for the daily number of visitors treated and plot the data on a control chart. All right. So we've got mu drawn out. So now let's look at, what did it say? Draw dashed control lines. Okay, so we need mu plus 2 theta and mu minus 2 theta, and then we need lines mu plus 3. I don't know why I'm saying theta, I mean sigma. Mu plus 3 sigma and mu minus 3 sigma. Okay, so if we look at this, well, what's mu? It's 21.7. So if we take 21.7 plus or minus 2 times sigma, well, sigma is 4.2, and if I do 21.7 plus 2 times 4.2, that is going to give me a value of 30.1, and if I do 21.7 minus 2 times 4.2, that's going to give me a value of 13.3. Okay. So what we need to do is draw dashed lines at 30.1 and 13.3. So let's go ahead and do that. All right, so I'll draw it about right in here. Okay. And then I'll draw another one down here, right about here. Okay. So this is 30.1, and this down here is 13.3. This is what? Mu plus, well, let me write it over here. This is mu plus 2 sigma, and this is mu minus 2 sigma. Okay, and then I need to draw dashed lines at mu plus or minus 3 sigma. So if I do mu plus or minus 3 sigma, which that's going to be 21.7 plus or minus 3 times 4.2, well, if I do plus, that's going to give me 34.3. And if I do this minus, that's going to give me 9.1. Okay, so I'm going to have a line down here, a dashed line, and then I will have a dashed line up here. All right. So let's see what we've got. This is going to be 34.3, and this down here is going to be 9.1. So this is going to be mu plus 3 sigma, and this is going to be mu minus 3 sigma. All right. So now we have everything drawn and labeled, and now I plot these points up here. See, this is my X value and this is my Y value. So let's go ahead and plot the points. All right, so Well, first, I guess what we need to do is let's go ahead and mark off the, let's see, I need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I got 10 days. All right. So now let's plot the points and see what happens. All right. So now I've got the point 125. So that's going to be about halfway in between there. It'll be about somewhere about right in there. And then I've got 219. Well, that's 21. So 19 is going to be probably about right in there. 317. That's going to be about right there. 415. And that'll be about right in there. 520. That's going to be a little bit closer to the line than 19. 624. All right, so 6, that'll be a little bit lower than that one. So maybe about right in there. 730. So that'll be right there almost to that line. 819. Let's see, that's going to be about right in there. 916. That'll be about right there. And 1023, which will be about right in there. And then what I'll do is you connect them with a line. And you can see from this graph, there's no out of control signal. Everything looks good. All right. So, you know, if you had, I don't know, if you had an out of control signal for this, that would, I don't know, maybe it might make you think, well, you may need extra help. Okay. You know, because you have more people being treated. So you might need extra help. But we have no out of control signals here. So I hope the video helped. Sorry about the program crashing and all that stuff, but you know it happens. So give me a like, share, and subscribe. Hope the video helped. Thanks for watching.